All right, Unit 4, Section 3. So we talked about parallelograms in the first section. We talked about rhombuses, squares, and rectangles in Section 2. Now we're going to add two more quadrilaterals. So the difference here is the first two sections were about parallelograms, figures that have opposite sides, and of course all those other properties, those 5 properties that we talked about in the first video. And then we added more specific properties in section 4.2 for rhombuses, squares, and rectangles. So now we're kind of going outside of parallelograms and going back to just quadrilaterals, so figures with 4 sides, and we're talking 2 specific types, starting with a trapezoid. In incredibly blurry fashion here, we have a trapezoid, what it looks like, and what it is a quadrilateral with 1 pair of parallel sides. So the difference between a trapezoid and a parallelogram is a trapezoid has exactly 1 pair of parallel sides. No more, no less. A parallelogram needs both sets of opposite sides to be parallel. So that means that this side and this side would have to be parallel, and clearly they are not. And then we have a kite. It's getting a little cold to be flying kites right now, but if you've ever flown a kite, you've kind of seen this shape before. And that is a quadrilateral with 2 pairs of congruent, here's the key, adjacent, meaning next to, oh man, let's try to spell that again. There we go, adjacent sides. So that means, this side and this side are next to each other and they're congruent. This side and this side are next to each other and they're congruent. That's what a kite is. Okay, so swinging on over, we got to talk some terminology quick of trapezoids. So first of all, we call those parallel sides the bases. Sides that are parallel to each other are called the bases. The other 2 sides are called the legs. And then if you run another line parallel to the bases, and it is, here's the key, because it's going to come up here in a little bit, the average of the lengths of the bases, that is called the mid-segment. So over here, an isosceles trapezoid, so it's like a trapezoid is just a general 4-sided figure with 1 pair of parallel sides. More specifically, we have an isosceles trapezoid, and similar to an isosceles triangle, that means, so we have our parallel sides, but it means the other 2 legs are congruent. So let's start there. So we have legs are congruent. That's an isosceles trapezoid specifically now. Also, we have base angles congruent. So that would be like this angle and that angle, and then these angles up here. So isosceles trapezoids are like super nice to work with because there's a lot of congruent information that you can get. And then last but not least, the diagonals are congruent. Again, these are properties specifically for that isosceles trapezoid, with the legs, starting with the legs being congruent. In general, so I'll zoom out so you can kind of see where I'm at here. Here are some kite properties now. So first of all, you can probably tell by this figure, but the diagonals of a kite are perpendicular. They form that right angle, and 1 pair of opposite angles is congruent. So in this example, A and C are the congruent angles. So hopping on over to the right here, find the length of the mid-segment. So I told you that this was going to come up, but the mid-segment is the average of the lengths of the bases. So how do you find the average? You add up the 2 pieces of information. So we're going to take 15 plus 23, and you divide by 2. That's how you find the average. So 15 plus 23 is 38, divided by 2 is 19. So that means the mid-segment would be 19. Now here it says to find the lengths for HE, it's right here, and FG. So what this is going to require is the Pythagorean theorem, which I'm going to write up here. I believe THM is just short for theorem, by the way. I believe you guys have talked about this in 8th grade math, and somehow, I don't know how it didn't come up in the triangles unit. I'm assuming, I don't know. But here it is, a squared plus b squared equals c squared. I know it is coming up. And so a and b really don't matter, but c is the hypotenuse of a right triangle. That's the only thing that matters. So when we're finding HE here, first of all, the highlighted or the colored side there, we're looking at this right triangle. And I know it's a right triangle because I have a kite, and a kite, the diagonals are perpendicular. So it's a right triangle, so let's just draw that triangle here. So there's a lot to focus on. Let's just dial it back to this. 3, 5, there's my right angle. So the side opposite of the right angle, that is the hypotenuse, HYP for short. And like I said, we're going to have to use the Pythagorean theorem, so we're going to go a squared plus b squared equals c squared. A and b don't matter. It's the legs. So this could be a, that could be b. It doesn't really matter. So we'll go 5 squared plus 3 squared equals. Now the hypotenuse is always c. That one does matter. C squared. Or if you want to call it HE, that's fine. So 5 squared is 25, plus 3 squared is 9. 25 plus 9 is 34, so that equals c squared. I want just c, though. So to get just c, we're going to take the square root. And there's no square root of 34. And I believe we're going to leave everything in radical form. Let's just go with that for now. So that means that C, which was also HE, is 34. I'm going to leave this next one for you. I'm going to help you draw it out, but it's FG. So it's this triangle right here. Same exact thing. So we have 9, we have 3, we have my right angle, and I'll even give you this. This is the hypotenuse C out here. So go ahead and use the Pythagorean theorem to find, what is it, G, FG. Oops. To find FG there. Okay, so I'll leave that one for you. And here's some more calculations again if you'd like to give it a shot. So first of all, the measure of angle E, well, it's a kite, so that means these angles are congruent. 85. Angle I is 85, so angle E is also 85. I'm not really sure when this is supposed to come up, but in a quadrilateral, this would be a great time. In a quadrilateral, there are always 360 degrees. So we talked about triangles. There are always 180, so every four-sided figure has 360 degrees. So what we can do is we can take 360, we can subtract the top 85 up here, we can subtract the 130 from here, we can subtract the 85 that we know is that, and if you do all that, you are left with 60 degrees. Yeah, I'm not sure when some of this is supposed to pop up, but a quadrilateral always has 360 degrees. All right, last one, find the value of x. So we know that the mid-segment is the average of the two bases. So that means that 17 plus 7x minus 5. These are my two parallel sides, they're the bases. If I divide that by 2, I get my mid-segment length. Well, in this case, I know it is 20. So this is the equation we're looking at solving. So I don't care how you set or how you start this. I personally would probably combine like terms here and here. So 17 minus 5 is 12. So 12 plus 7x divided by 2 equals 20. The next thing I personally would do is get rid of this fraction. So we can multiply this side by 2 and that side by 2, and it gets rid of this. And leaves me with 7x, or 12 plus 7x equals 40. Subtract 12 from both sides. Oops. Now this doesn't look like too tough of a problem. 7x equals 28. Divide by 7. And x equals 4. Directions say to solve for x. We solve for x. And that'll be it.